And good morning, everybody. Thank you for joining Tech Thursday with Set Solutions. My name is Michael Farnham, CTO with Set Solutions. Real quick rundown of Tech Thursday for you. So for those of you who have not joined or not joined before, or actually for those of you who have, thanks for rejoining. For those of you who've not been on one of our Tech Thursdays, this is a kind of an inside view of how Set Solutions stays up to date on all technical things, and so we can provide more value for you. So we do this on a regular basis internally with our partners, and we're bringing this to you to give you a view of that and how we stay up to date. So again, thanks for joining. Today we have Contrast Security, who is going to be showing their products, their features, and all things around application security. Jeff Williams, who is the co-founder and CTO at Contrast, will be presenting today. We also have Jay Douglas and Dustin Soward from their side, who will be also doing have some part of the presentation. Jay is going to be answering questions on the Q&A panel, so please use that Q&A panel as you have questions that come to you. Jay will be answering those online, and we will also be presenting some of those questions towards the end. And if something's really a good question, we may interrupt Jeff during his presentation. Jeff's very flexible on that kind of stuff. So he'll answer those during the session. Also, before we get started, just want to let you know that if you registered for this, you will be getting a questionnaire/survey in your email inbox. Please fill that out. If you can fill that out, you will be entered into a drawing for a gift card from Contrast. Also in that, you will get a link to the presentation that Jeff has today. You will get a link to the video at some point once we get this recorded and get the post-production stuff done and get it up on YouTube. And also, and I'm going to let Dustin talk about this in just a second, you will get a link to the work from home kit that Contrast is offering. So at this point, Dustin, why don't you go ahead and tell them about the work from home kit, and then we'll let Jeff get started.
Thanks, Michael. Yeah, guys, again, thanks to everyone for attending. We're going to be covering some really good information. Obviously, we have like an hour, so there's going to be additional questions, I'm sure. So we have a really cool work from home kit that basically, if you take another meeting with us to kind of get into more detail around your environment, we've got some skull candy noise reducing microphones, or headphones, I should say, a desktop microphone, and a Wi-Fi range extender, and then some blue light glasses for you. So cool swag if you just take the time to give us another hour of your time. Thanks, guys.
All right, Jeff, take it off.
Okay, thanks. I just texted my wife to tell her to try to keep the dog quiet. Sorry about that. So good morning, everybody. My name is Jeff Williams. I'm the CTO and co-founder at Contrast Security, and I've been working in application security for over 20 years now. Along the way, I started a consulting company, and I worked with many very large financial institutions and insurance companies and entertainment companies and airlines and so on their application security programs. I also helped to start OWASP, the Open Web Application Security Project. I was the first global chair there, and I ran the organization for almost 10 years. Today I want to tell you a little bit about Contrast. I wanted to start by just talking about application security and how important it is. You know, these days, application software is transforming everything. It's actually increasing in the age of COVID. And unfortunately, we're pretty terrible at producing secure code. And I'm a little disappointed about that. You know, I wrote the OWASP Top 10 in 2002. And in 18 years, we've made basically zero progress. Still today, you can see some of the statistics here. You know, 96% of applications have a vulnerability. The average software project introduces almost 2 vulnerabilities every month. And that's just in the custom code. If you include the libraries, they've got over 2 higher critical flaws in their open source libraries. The average application has, in the high 20s, low 30s number of vulnerabilities overall. So, we're really not doing very well at writing secure code. And, that might be tolerable if the attackers weren't out there attacking. But unfortunately, the average application's attacked over 13,000 times a month. That's a pretty crazy number. And there were 0 applications that were not attacked at all. 98% of those attacks are just dumb scans. They don't even connect with the vulnerability that they're targeting. Like it might be a command injection attack that doesn't connect with the use of the operating system in an application. But it's a flood of data. 2% of those of 13,000 is a pretty healthy number. So we got to be careful. We got to do better. If you want some more statistics on things like this, we just published our 2020 AppSec Observability Report. It's about 50 pages full of details on the tens of thousands of applications that we monitor for security. And you can see kind of the relationship between vulnerabilities and attacks. Okay, so look, the whole point of IT is to deliver value to customers faster. And when you do security the traditional way, typically, developers write some code, they check it into some pipeline, or they run some scan kind of tools. They probably run a SaaS tool in their IDE. Maybe they run software composition analysis to analyze the libraries in a full SaaS somewhere. They may use dynamic scanning tools later on. They may do pen testing. They may have a WAF. The problem with all these techniques is that these tools are noisy. They both miss vulnerabilities and they find a lot of things that are really false positives. And so you have to have skilled people triaging all of the output from these tools. And there's just not enough experts to deal with this. So, you got all these activities doing extra work here that doesn't really provide much value. And at the end of the day, all these extra steps and checks, they slow down the delivery of value to customers. And that's the problem that most organizations are having. I've worked with hundreds of organizations that don't do AppSec on their whole application portfolio. They only focus on, say, the critical applications. And the level of rigor that they use is pretty low. They're not doing any sort of complete AppSec on all of them. So you end up with this giant security backlog, and the developers, choose some of those things and fix a few things over time, but it's really slow. And ultimately, that's slowing innovation. It doesn't have to be this way, but we have to think of ways to fix the economics here. We've got to fix the scale problems associated with AppSec, or it's never going to get better. So I believe we need to move away from the scan and firewall model. So all those tools, SAST, DAST, WAF, all came out in the early 2000s, right about the time when OWASP was getting started. And they've got this accuracy problem, which means that they're disruptive. They create bottlenecks, they use a ton of experts, and really they're kind of reactive. You don't get real-time feedback. You just get a scan at a particular point in time. And those tools aren't very integrated. So you have to run a SaaS tool and a DAST tool separately, and they're not really linked together. So you end up with all this duplication and extra work. I'm convinced that the right approach going forward is what I'll call the embedded model. This is where we use instrumentation to get the security analysis inside the application itself, where all the context is, so that we can be much more accurate about finding vulnerabilities and identifying attacks. This is exactly the approach that tools like New Relic and App Dynamics use for performance, but we're doing it for security. So we instrument the application with tiny sensors that just measure what's going on in the application at particular security relevant places. And then you use the application normally. Note that I said you don't have to be an expert to use this, right? See, a developer can just do their normal job, their normal development and testing activities, and Contrast will be there in the background doing the security analysis and giving them instant feedback on what they're building. That's how to use software development as a force multiplier so that the experts can focus on the harder things like security architecture and threat modeling and things like that. But we've got to empower developers to create their own secure code. So Contrast runs in the background, it's continuously running there, and it works in parallel across all your applications. So it's not scanning one by one. All your applications are monitoring themselves in the background and reporting data. So let's take a look at how this works. So there's really two industry terms here that you should know about. The first is IAST, or Interactive Application Security Testing. All that means is that you're using instrumentation to detect vulnerabilities in an application while it's being used normally. RASP, or Runtime Application Self-Protection, is simply using instrumentation to detect attacks and to prevent vulnerabilities from being exploited in an application. Typically, you use IAST during development, when you're building the code, maybe when you're testing it, and then you use RASP in production, where your applications are running and you want to defend against attacks. So that's it. These are the new technologies in AppSec. Now, Contrast, we provide both IAST and RASP. We also do software composition analysis, and we do it all in a single platform. So we've integrated these capabilities. So you don't have to buy tool soup anymore. You can get one product. The way it works is you take our agent, and this is an application layer agent, just like New Relic or AppDynamics. It's not an operating system level agent like your virus detection or something like that. You take this component and you add it to your application environment. So you add it to your app servers. For these platforms, we support Java, .NET, .NET Core, Node.js, Ruby, and Python. You add that to your application. I'm going to demonstrate this in just a second. I got about 2 more slides, I think. And then as you use the application normally, Assess goes to work finding vulnerabilities and reporting them to our central team server. Contrast is a SaaS platform, so it reports to our dashboard. We do have on-premise support, but most people use our SaaS. And so you get all your vulnerability information about all your apps in parallel in one place, all integrated. We also analyze all your open source code for both license problems and known vulnerabilities, and that also goes to the dashboard, so you can see that as well. And then in production, Contrast switches gears. Most people don't use Assess and OSS in production. They turn on Contrast Protect, and that's where we're preventing your application from being exploited. It's great for legacy applications as well as new development. So let's see, when we put this all together, let's see how this works. So I want you to imagine that you're an organization, you've got apps that are in development and integration and test, they're in production, and you're constantly changing these things. Contrast is there. This little, this sort of represents our analysis. It's in all of your platforms. So in the background, Contrast is continuously analyzing all this stuff. Anything that it finds, whether it's vulnerabilities in development or attacks in production, it reports those to the Contrast team server, where we've got great dashboards. I'll show you this in a second. And you can keep on top of application security strategically. We don't stop there. We actually feed that data back to the people that need it through the tools they're already using. We've got a ton of integrations into, this is just a sampling of the kinds of tools we integrate into. All the major IDEs, chat tools, bug trackers, CI/CD tools, and in production into SIMs so that you can get it right into your SOC. We also try to make it easy to deploy, so we support all the major cloud and container environments. We try to make it really easy to add Contrast to your applications. Microsoft is an investor in Contrast in our C&D rounds. We've partnered with them very closely, so you'll find Contrast integrated into all the different parts of the Azure DevOps pipeline. Okay, so I just want to give you the vision here, and then we'll take a look at the product. So I just want you to imagine what modern security looks like. Contrast injects analysis into the application itself, and then as the application's being built in the normal development pipeline, vulnerabilities are getting discovered, they're getting fed back to developers, attacks are being identified, that feedback is going back to whoever needs it, including developers. And that feedback loop takes about 1 second, by the way. So you'll see, in the demo, you'll see real-time feedback on vulnerabilities. And what that does is it enables developers to know that they're secure. They have confidence that everything's being tested continuously. They can go in the dashboard, they can verify that it's all been tested. And that gives them confidence to push software into production at whatever velocity they want to go. Their waterfall project, that's great. They can use contrast. They can release on schedule without a fire drill. But if they're a DevOps project and they want to release multiple times a day, this allows security to be a real part of that process. And that's really the essence of DevSecOps, is bringing those pieces all together in a way that actually works. Okay, so let's take a look at contrast. So I'm going to bring up the main contrast dashboard here and just give you a sense of the scope of the project. So here's my main dashboard. You can see I've got 23 applications across 4 servers. We have customers that have thousands of applications across thousands of servers. So contrast is a very scalable technology because the work is distributed across all your application servers. So it scales really well. And you can see overall, I'm not doing that well. I've got a lot of custom code vulnerabilities. I'm actually doing okay on libraries in terms of vulnerabilities, but overall, I've got a sort of a D score. You can see in the dashboard here, I've got a lot of vulnerabilities, a number of criticals, a lot of highs. And you can see I'm currently being attacked. That's really not a great place to be. If you're both vulnerable and being attacked, contrast is really the only application security technology that can show you the full picture in one dashboard. If you wanted to build this with legacy tools, you'd have to, take the SAST results and the DAST results and the SCA results, integrate them all and deduplicate them, then get the WAF results and pull those in and sync them up with the vulnerabilities. And I've just never seen it successfully done. Okay, so that's sort of the high level dashboard. Let's drill down a little bit. I'm going to show you how to get started with contrast. And fortunately, it's pretty easy. You start by adding the agent to the application. And I'll show you, this is the hard way of doing it. It's sort of the manual way of downloading one of the agents for whatever language you're interested in. I'll download the Java one here. It's about an 8 megabyte jar file. It's really pretty tiny. And then we're going to add that to our application. So I've got an application in Eclipse here. You can do this either in the IDE or you could do it in a test environment. Wherever your application is running, you can add contrast. So you see I've got my contrast.jar file here. And to add it to this application, I can just go into the way this application runs. This is I'm doing it on an application called Spring Pet Clinic. And it's a pretty typical Spring Boot application. So it launches with the Spring Boot plugin. And I just add the Java agent flag and point it to my contrast.jar. That's really it. We do have a local configuration file you can use, but it's not required. Contrast will work right out of the box on most applications. So that's it. You just add this one flag and run your application again. You can do this on anything that's written in Java. And so I'm going to, now that I've set it up, I'm going to run the application just the normal way I run it. I don't have to do anything special. And essentially what happens is, as this application starts up, contrast will instrument it. So all the instrumentation happens during startup as the code is actually loaded into memory. And then once that happens, you can see here's the process has started. It started to instrument the application. Once the application is instrumented, then you just use it normally. It's as though you wrote that protection into the application itself in the source code. But you don't need the source code to do this. You can use contrast on an application that's completely compiled running on a server. Okay, so then all we have to do is use this application normally. So I'm just going to browse around, and in the background, contrast is testing this application. I'll put demo Thursday here, so we'll have something we can look up in a second. And this makes it really convenient for any developer to do their own security testing. You can see I'm not doing anything particularly special here. I don't need to know anything about security to do this. So I won't go through the whole application, but you get the idea. Contrast is in the background doing all these checks and reporting them all to the contrast team server. So let me go back to the team server here. And what happened was this application registered itself with the contrast team server and added itself to the application inventory here. So now I've got an application here, Spring Pet Clinic. I'll click into that, and you can see I've got a live dashboard for every one of my applications. It shows me, hey, I've got 150 libraries with a number of vulnerabilities. I'll talk about route coverage in a second. You can see what the application looks like in both development and QA. If I run my test cases on this application, it'll report into the QA section here. And that's actually kind of important because you want to know that you're finding vulnerabilities in development and not delaying that process until QA. It's much more efficient to fix them in dev. So let's drill down into the vulnerabilities here and see what we found. So you can see just within the last 2-3 minutes, Contrast discovered a whole bunch of interesting vulnerabilities. You can see it's got some injection kind of vulnerabilities, stored cross-site scripting, which is a little tricky. We also analyzed the code itself. So Contrast does static analysis in the background, and it found hard-coded passwords and weak encryption algorithms, things like that. You can see Contrast also analyzed all the HTTP traffic, a lot like a DAS tool, and to find missing headers, failure to detect clickjacking problems and parameter pollution and things like that. So really, Contrast did a very broad analysis of the application. You'd have to run multiple different tools to get this depth, and it did it in just a couple of minutes with no extra work on anybody's part. So we can click in to this Hibernate injection vulnerability. Hibernate injection is very similar to SQL injection. And you'll see we created a great finding here. It says Hibernate injection from the last name parameter on this particular page in the application. We started a timeline so we can track how long it takes to fix. And Contrast will actually detect when this vulnerability gets fixed, and it'll close this. It'll close any associated tickets if you've got a Jira integration set up. And this is really the beautiful part to me. We captured the whole story of this vulnerability. And this is why getting inside the application to watch the actual flow of the code is so important. We tracked some data from the HTTP request, this last name parameter. Remember I typed in demo Thursday? And we watched that data as it flowed through the application. It ended up in this method on this line of code. And it ended up as part of this Hibernate query. You can see exactly where that data landed. And what Contrast is telling you is that that data was not properly escaped or parameterized in a way that would have stopped SQL injection. So we've confirmed that this is a real vulnerability. We see the data is actually flowing through the application. We didn't have to guess about that like static tools. And we confirmed that the right defenses are not on that path anywhere. So we know that this is an exploitable vulnerability. Of course, we've got all the details. If you want to dig into this, we've got all the details of all the sensors that this vulnerability encountered. You can see the exact line of code where this parameter was read in. You can see all the, how this query was built up. There's multiple calls in here about how this data was concatenated into the query. And then there's this last line. This is the line of code where this data was actually sent to the database. And you can open this up and see, all the details. You can even see the full stack trace recorded directly from the running application. So it's not just, a hypothetical stack trace based on static analysis. This is the actual one, and it includes the whole stack all the way down, through Spring and all the way to the application server. So all the details anybody could want to very quickly be able to understand and fix this. We also include the full HTTP requests. And this is interesting. If you've used static before, it's great. It tells you a line of code, but it doesn't tell you how to test it or verify that you fixed it. So Contrast provides that. We've captured the HTTP request here. You can see I can replay this, and I've got an automatic test case so that it can verify that I fixed it correctly. And of course, we give you the details on how to fix the vulnerability. In this case, the solution is replace the query with something parameterized that uses bind variables. It's probably the best thing to do. So, all the vulnerabilities are like this. They've got a complete story about what's really going on. You can see, CSRF is another interesting one. Very difficult for legacy tools to detect this because they don't know which transactions are state changing. That's very difficult for both static and dynamic tools. Contrast can tell we can show you the actual query that caused the state changing operation. You can see here, if you visit the new pets interface, you can see there's an insert query that changes the state of the application. Because it didn't have a transaction token, we know that this is exploitable by an attacker who wants to forge these new pet transactions. There's kind of the level of detail that Contrast can provide. Let me show you here the idea of route coverage. So one of the challenges that every application security tool has is making sure that you've covered the entire application. Static tools, you'd think that static tools, obviously DAS tools struggle with this because they have to crawl the web interface to try to reach the whole application, and they don't do a very good job. Static tools seems like it would cover every line of code, but that's really not how they work. Static tools take your source code and build a model of the application. Then they have to identify the entry points and sort of crawl the application from there. And they don't do a very good job of that. So they miss a lot of code. Contrast, on the other hand, we actually analyze the running application. We identify all the exposed endpoints by interrogating the application itself. And then so that's sort of the denominator. And then we track how many of those routes have actually been exercised during the normal development and test process. And we report that to you. Most organizations without any extra work get to 70+% route coverage without doing anything special. That's far better than what you can get from SAST or DAS tools. But we also give you a path to get to full coverage. And so I've currently covered all 28 routes here. But if I hadn't, I could pull this down. I could pull up the not exercised routes, and I could show them to you. In fact, this route was not covered initially when I used this application, and I actually dug into it. It tells me that this /manage/loggers route is available. So I went to the application. I was just like, well, let's just see what that does. So I went to /manage/loggers, and it dumps out all this, this debug information about the logging infrastructure. I dug a little further in the contrast results, and it also told me about /contrast/env, which points out all the environment variables in use. This should definitely not be exposed. And I call these hidden routes. Contrast exposes these where other tools would have no way of knowing about this. Turns out these hidden routes are actually added by Spring Boot, and a static tool would never notice this because it's not even in the source code that's being analyzed. This is, again, sort of added by the infrastructure. So just a little bit about the power that Contrast brings to getting you to really good security coverage. Okay, so the next thing here is Contrast also analyzes libraries. So I want to show you what we do here. Contrast automatically identifies all the libraries in this application and tells you which ones, which exact version you're using, what the latest version is, and if there's any known vulnerabilities associated with that library. And it's interesting, there are other tools that can do this kind of on a scanning kind of approach, but Contrast, because we're in the application itself, we can see how much of that library is actually being used. And one of the interesting things is that a lot of these are zeros. You can see, these ones that are flagged unused. This netty library is never invoked. And that's actually really important because if there are vulnerabilities associated with this, they're not really presenting a risk to you. So these would be false positives that other tools would report. Contrast actually also analyzes not just the stuff in the repo, but also the stuff, all the libraries associated with your environment, everything that's running on the Java VM. So you get a little bit of coverage here. It turns out actually 55% of Java libraries are never invoked and don't present any risk. And of course, you can drill down into these so that you can see the exact vulnerabilities. You can see exactly what servers this library is being used on, and get remediation advice on exactly what you should do about this. We also have a hierarchical view here that will show you, let me expand all here, and I'll just show just the vulnerable ones. And what this shows me is that, say, this Tomcat embed core library has a vulnerability, has a number of vulnerabilities actually, and it's included in this application because of the root dependency, this Spring Boot starter web dependency. So that's what the developer would go to fix. They would update this 1.5.4 version of this, this particular dependency, as opposed to trying to replace this library specifically, which is be very difficult and kind of a waste of time. So that's two things Contrast does. We analyze your custom code for vulnerabilities. We analyze all your libraries for vulnerabilities. We also show you if there's any license problems with this library, like you can see the exact license that's used in each of these applications. But now I want to move on to the third thing, which is the Rasp protection, that we actually protect this application in production. So I'm going to go to this application we've been looking at here, and let's bring that back up. And I'm going to go to that Hibernate vulnerability that we found, and I'm going to exploit it. So this is a Hibernate injection attack. And when I exploit this, I get all the data out of the database. So, any records that are in there. So it's pretty typical Hibernate injection. That's because in my development environment, I'm not using Contrast Protect. But I have another environment set up here where I am using Contrast Protect. You can see I'm running on a different port here, running this with Contrast Protect. And here I can use this application normally. I can browse around. You'll never know that Contrast Protect is there. But when I go back and exploit that vulnerability, that's when Contrast comes to life. Contrast observed this transaction. It analyzed the data coming in, tracked it all the way into this query, and said, hey, this user is trying to modify the meaning of this SQL query. That's never allowed. And it prevents that query from going to the database. So this is much more efficient than a WAF. The WAF only has the HTTP request to go on. And so, this attack that I just sent is pretty easy to identify, but an attacker could make this much more complicated. This 1=1 expression, they could replace that with any expression, any legal SQL expression. They could replace it with that and make it much more difficult. They could encode it. They can do a whole bunch of tricks. Because it's basically these days, it's impossible to identify attacks simply by looking at HTTP. Matter of fact, almost every HTTP request looks like an attack these days because it's all JSON and serialized objects and WebSocket and complicated data formats. But Contrast sees the data the way the application sees it. It sees only the little piece that's actually going into the database query, and it analyzes the structure of that. So let's take a quick look at that in our Contrast dashboard here. So I'm just going to go to the attacks dashboard here. And I'll go back the last 30 days so you can see kind of some of the scope. I've had a bunch of attackers across a bunch of different kinds of attacks, including CVEs, by the way. So it's not just custom code vulnerabilities. This is attacks on known vulnerabilities as well. Contrast is in place. It's protecting you from having any vulnerabilities in these categories being exploited. And we can drill down into these. I actually like exploring it here. You can see like, what did this attacker do? Show me the SQL injection vulnerabilities and so on. So there's a lot of ways to slice this. I'm going to clear these filters and just show you the range. I'm actually going to show you all the attacks. So this is all the different kinds of attacks, and you can see the payloads over here, all the different attacks that Contrast is identifying, from path traversal and cross-site scripting and SQL injection, expression language injection. You can see here tons of different kinds of attacks. And I'll show you the attack that we just did here a second ago. You can get all the details. Contrast shows you, here's this data that came in. We traced that through the application all the way into the query, kind of like the way we did to identify this vulnerability. But now we've tracked attack data into this vulnerability. Contrast analyzes this query and determines that this query actually modified the semantics of the query. That should never happen. And so that's when contrast intervenes. That's why it's more accurate than a WAF. It's because we're actually checking, the definition of hibernate SQL injection here. And we got all the details. We've got the full stack trace. This is a little unique, right? A WAF can't show you the exact line of code that this vulnerability occurs on. So it helps, if you are successfully attacked, it helps you track it back directly to the line of code that needs to get fixed. And of course, we got the full HTTP request here with all the, the details. There's a ton of workflow throughout Contrast. So here you can see there's a discussion on this so that your team can collaborate. You can also, create bugs and track them in Jira and all kinds of that kind of workflow. So with that, let me go back to the main dashboard here and just summarize for a second. So with a pretty minimal amount of trouble, we were able to add Contrast to this application, use it normally. We identified a bunch of vulnerabilities. We identified the library problems that need to get fixed. And we even enabled Contrast Protect so that we can keep using this application in production while we go back and clean up the code and fix those vulnerabilities. That's a powerful approach to application security. We're seeing it work at large scale. And I've got one last slide I want to show you to demonstrate that. This is directly from the 2020 observability report that I mentioned. And what I'm showing here is vulnerability remediation rate. Because ultimately, I think where you want to get to is, it's kind of what I call the new normal. It's where you've cleaned up your backlog and you're fixing new vulnerabilities as they come in. So, if a developer creates a new vulnerability, they get instant feedback, they fix it instantly, check in clean code, and you're back to secure. Instead of, a lot of organizations I've seen, they carry a big backlog all year, and then there's a hurry up to clean that up right before the compliance check. And then by the next day or two, they're already back out of compliance because they've introduced new vulnerabilities. So we want to try to fight that. So this chart shows the red line is static analysis. And these results are from Vericode's State of Software Security report. And you can see that, with SAST, you can hope to remediate 29% after 30 days. After 4 months, you can get to halfway. And by the end of the year, you might be able to get to 71% of your vulnerabilities closed. I don't think that's good enough. So what we're seeing is this green line. This is across all of our customers. The average numbers are that we get to 50% remediation in 7 days and 61% by the end of the first month. And then by the end of the year, we get to 90% remediation, which I'm super proud of those results. But I'm even more excited about the next line, this white line. This is for our customers that have below average backlog. That means that they've worked on their backlog and they're working off the vulnerabilities that are there. Those customers are closing 75% of their vulnerabilities in just 8 days. That's more than with SAST you could close in the whole year. And by the end of the year, we get to 95% closed in the first year. To me, this is the metrics that demonstrate what shift left actually looks like. This means that development is doing the bulk of the work and closing these vulnerabilities. That's the most cost-effective way of doing application security. I think this is a healthy lifestyle for people to, if you think of your development program as a lifestyle, then this is the way you should be living. It's staying healthy all the time. So with that, I'll stop, and I'd be happy to take any questions that you have about Contrast or application security in general, whatever you'd like.
So I think Jay answered one of the questions in chat. So I don't know if you want to dig into that a little bit. It's does IaaS dig in that app hosted JavaScript to identify DOM vulnerabilities, or do you still need to supplement with dynamic scanning to identify those?
That's a great question. So DOM XSS is, it's kind of one kind of XSS, which is one kind of application vulnerability. And Contrast doesn't do anything to help you with DOM-XSS right now. In fact, there are really no good ways of automating DOM-XSS detection. There was a tool by a company called Minded Security in Italy that did something like contrast for DOM-XSS, but unfortunately they couldn't find a market for that tool. I think the problem is that really the important vulnerabilities are on the server side. Most client-side vulnerabilities aren't that attractive to attackers because at best you can compromise one victim at a time, whereas on the server side you can compromise many victims all at once. So there's just much better payoff. It's not to say I wouldn't love to address DOM-XSS. It's just not something that you can really find very accurately with DAS tools. SAS tools will claim that they look for it, but unfortunately, JavaScript is such a difficult language to analyze statically that they're not effective. Probably the best thing you can do about DOM-XSS is to just really manage your JavaScript libraries and make sure you stay up to date on the latest ones. There's an open source tool called retire.js, which is pretty effective and easy to use. It'll find those out-of-date libraries and get you to update them.
So, Jeff, one of the questions I've asked a lot, and it comes down to open source libraries, just third-party libraries in general. When you bring those on, when in my past working at a different SaaS AppSec vendor, the issues we had a lot was around being able to bring third-party libraries in and do SAS scanning with them, and how much time it would take. And I know you dug into that a little bit, but is there any detail you can give on how, from a IaaS standpoint, being able to look at those third-party libraries differs a lot from how SAS does it?
Yeah, that's a great question. So, it's hard enough for SAS tools, static analysis tools, to analyze, just the custom code. Many applications we see these days have, hundreds of thousands of lines of custom code. Some have millions. And that's a lot for a static analysis tool. Like, just doing that is going to take definitely hours for a static analysis tool to analyze. And that just doesn't fit into your modern CI/CD pipeline. Most of them have SLAs on how long they can take. It's usually like 10 or 15 minutes to run. And so you can't take a 2-hour scan and jam it into a 15-minute pipeline. So that creates a ton of problems. But when you introduce the open source libraries, you're adding hundreds of millions of lines of code to an application. We see applications that have hundreds of libraries. Many of them are huge. And there's just no way for a static analysis tool to build an accurate model of all of that and then traverse it effectively. It would take so much memory and so much compute time and so much energy, you'd harm the planet. So nobody does that really. SAS tools make a lot of assumptions about what happens within libraries, and they're not very accurate. Tools like Contrast don't have to make those compromises. So we analyze everything that's running on the JVM, whether it's custom code or libraries or frameworks or whatever. Because we're just watching the application run, it doesn't increase the compute time for us. And we only analyze the parts of the application that are in use by the application. So there's tons of dead code in libraries. In fact, I did a study on this once, and it showed that only 20% of all that library code ever actually runs. In fact, in most applications, the amount of custom code that runs is bigger than the amount of library code that runs, even though the total amount of library code is many times more. So I think the way that we analyze applications, it does two things. One, it'll show you the known vulnerabilities in libraries, and we do that roughly the same way that other tools do, except that we do it at runtime, right? We're just identifying the library, and we look it up in a database that says, hey, this library's got known vulnerabilities, please upgrade it. But we also analyze the entire application, including the libraries, for any custom code, for any custom vulnerabilities. So things that are not known yet. And we pretty regularly discover 0 days in libraries, just because, you know, we're watching them as they run in real context of real applications.
And for one of the offline questions I've got is around how you help enable logging of applications. Maybe if applications don't have a lot of pre-built logging into them, is that something you can help with?
Oh yeah, that's a cool question. So we have a feature, I didn't mention it in the demo, but it's called log enhancers. And basically what we can do is weave in security logging into an application that doesn't have good logging. We can add it at runtime. So we've got a bunch of log enhancers pre-built that add in security logging for struts and Spring and a bunch of other things into applications that don't do it, so that you can see things like failed authentications and failed access control checks and unauthorized access and things like that. You can get really good log data about that. But you can also create your own custom log enhancers. And it's pretty easy. You just specify the method and then what data you want to get out of it. You can put in a format for the log message, and then you're off to the races. And Contrast just adds that logging at runtime, so you don't have to go back and change the code and rebuild the application and retest the application and redeploy the application. We can just do it at runtime.
Yeah, I know from our side that, especially when we're helping somebody with the data analytics side and they're asking us for different sources to feed into, whatever SIM tool and data analytics tool they're using, when they ask something from an application standpoint and they have lack of logging, something like this could really reduce our frustration when we run into that. It can really help enhance the correlation capability of whatever tool they're using. So that's a neat feature. I really like that.
Well, I hate to say it, but most application logs are kind of a mess. It's kind of up to the developer what they log, and there's not a lot of consistency around logging in general, much less security logging. And so, trying to make conclusions about what happened during an attack based on application logs is pretty tough. So we're hoping to try to fix that by weaving in some standard security logging into applications.
Awesome.
Hey, Jeff, real quick. I know most of the folks on this call today are on the security side, so are very well and very familiar dealing with the friction between security and development. I know you kind of broadly brushed on it, but could you just add a little bit more color on how we solve for that?
Yeah, so, developers are incredibly busy. They've got an incredibly difficult job. It's very difficult to keep up with modern software development. There's new frameworks and new programming paradigms, new languages, new everything. I think people in security complain a lot about how fast security moves, but, never mind. I think development moves much faster. And so there's not a lot of room for developers to become security experts. I did a ton of security training. I've taught secure coding classes for many years. And, I think all developers, they want to do the right thing. They want to understand how to not make these mistakes, but they don't really have time to waste a ton of time, running a complicated security tool that requires expertise they don't have, and deal with a ton of false positives that don't give them enough information to triage. And so, to me, the answer is we have to do better at security tooling. We've got to give developers tools that are designed for them, that work in their environments without a ton of extra work, and that give them, useful information that they can put into practice without huge amounts of distraction. So, I think we've built that trust with our customers. We've got a lot of customers that take our vulnerability information and send it right to developers without having to go through a separate application security team. And really, ultimately, I think that's the only way that we can scale AppSec, is to try to make it fit into the modern development process. If we continue to have separate processes, separate tools, separate practices, it's never really going to succeed. It's going to remain on the margins, and we're never going to make any progress in AppSec. I don't want to be here after another 20 years saying, well, it's still the same stuff in the OS top 10. That would be really disappointing to me.
Cool.
Yeah, I appreciate that that question a lot. It has been frustrating over the years trying to bring those two together, and anything that can make it easier for the developers and still give us the insight we need, and that's something we need to work on. So I appreciate that question a lot. Any more? I don't see any more questions in the Q&A. So I think we can, unless something pops up, or if anybody else wants to add anything, I think we can call the end of this. Jeff, I really appreciate the time you put into this, and everybody at Contrast, thank you for joining us on this Tech Thursday, and everybody that joined us as well in the audience. I appreciate it. Thank you very much. Hopefully this was a good presentation. If you got any questions about this, feel free to reach out to your account manager at Set Solutions. We can definitely help you out. And again, remember that work from home kit, if you just give them an hour of your time and let them dig into it a little bit, you can get that work from home kit. You'll get that link. I think that link's in the chat, and there's also going to be a link sent out with the questionnaire. Please, again, fill out that questionnaire, and you can get entered into the drawing for a gift card from Contrast. I think we'll call it a day. Thank you, Jeff. Really appreciate it, and everybody at Contrast.
Thanks, Michael. Great to be here.
Take care.
Have a good day.
Bye, everybody.